Alright, so at this point, we're all pretty well decided that the next stop for humanity in this solar system is going to be the planet Mars. The moon was our first giant leap, and for an accomplishment made in the 1960s, it was one hell of a leap. But setting foot on Martian soil is going to be a whole different league of exploration, and that is going to be amazing. There are decades worth of exploring to be done on the planet Mars at least, but we are naturally curious people, of course. So we can't help but already wonder, where do we go next? Is there a step further after we conquer Mars? Is that even possible? Well, I'm going to wager that it's not only possible for humans to travel beyond Mars, but it is actually inevitable, because we can look at Mars like a stepping stone, a kind of interplanetary foothold that allows us to cross the Great Filter and travel a road that stretches throughout our solar system and into the unknowable beyond. The Martian spaceport. Trippy stuff, right? But it's all a matter of science, and it's surprisingly not even very difficult. So, let's talk about the real reason that we need to go to Mars. This is the space race. So the first thing we have to acknowledge is that the Earth itself and the characteristics of this planet are the biggest obstacle to passing the Great Filter. I mean, gravity and atmospheric pressure are amazing for allowing us to live comfortable, day-to-day lives, but they also make launching spaceships from the Earth a huge pain in the ass. We live on the most dense planet in the solar system with a very thick atmosphere. So anything trying to go in the upwards direction is going to meet a lot of resistance along the way. This is something that Elon Musk talks about pretty often, that the gravity and atmosphere of the Earth make it very difficult for us to reach the effective amount of mass to orbit that it will take to make human life multiplanetary. During an interview at the Wall Street Journal CEO conference last year, Elon was trying to explain why his Starship project was so important. And Elon said that right now, our rockets can only get around 2% of their total liftoff mass into orbit. He didn't say exactly what altitude of orbit he was talking about. It obviously depends on how high you want to go. Falcon 9 can put about 4% of its total mass into low Earth orbit, but only about 1.5% of its mass to geostationary transfer orbit. So I think he's just making a generalized average here. But the point is that it takes a massive amount of resources on the ground to get a very small amount of resources into space. And Elon was saying that with the SpaceX Starship program, he's hopeful about getting 4 to 5% of the ship's liftoff mass into orbit, which in this case would be at least 100 metric tons of cargo, if not much more. Because we also know that SpaceX has switched up the design for their latest iterations of the Starship second stage and added 3 more Raptor vacuum engines to the thrust section. Those are the big, wide nozzle engines that are optimized for use once the ship gets to space. SpaceX are also extending the fuel tanks in the Starship as well. We know that for Elon Musk, mass to orbit is the most important factor for accomplishing a multiplanetary civilization. He's been talking about this for years, and it's the reason that the Starship is so gigantic. It must be both fully reusable and a super heavy lift vehicle at the same time. When talking about this problem, Elon told the Wall Street Journal audience, quote, "It is so preposterously difficult that there are times where I wonder whether we can actually do this." On the subject of mass to orbit, Elon wrote in July 2020, "To revolutionize space, the right metric is mass to orbit, or you could translate that to the number of useful satellites brought to orbit. No substitute for mass though. Scale don't lie." March 11th, 2021, quote, "Our fundamental constraint is mass to orbit per unit of time. Last year, SpaceX launched roughly double the payload mass of the rest of the world, but those are still rookie numbers compared to what he has in mind for Starship." At the height of his frustration around Raptor engine production after the notorious leaked email about SpaceX facing bankruptcy, Elon wrote, "The magnitude of the Starship program is not widely appreciated. It is designed to extend life to Mars and the Moon, which requires about 1,000 times more payload to orbit than all current Earth rockets combined. Let that sink in for a second. 1,000 times more lift than every single rocket on Earth combined. If anyone ever asks why we're not living on Mars or even the Moon, that's the reason. If people are going to go somewhere interstellar that we've never been before, then we're going to need to bring stuff along with us. A lot of stuff. Sending people to land on Mars with just one ship full of supplies or even a couple of ships is not going to work for a mission that will be at least 2 years in duration. It would be like trying to live on Antarctica with just one backpack full of supplies for 2 years. It might work out for a few days, maybe you make it a week or so, but inevitably you would be doomed. Or, I don't know, maybe you become ruler of the penguins and they bring you fish every day and everything turns out great. I'm just trying to use a metaphor. That's the thing about science fiction and futurism and all of these amazing renderings of what a giant moon base would be like, or a city on Mars, or a city-sized space station. They always gloss over one very important detail. How did it get there in the first place? I guess we always just assume, well, someone will figure it out. Elon Musk seems to be the first person to actually put in the time trying to figure that out, and this is his best answer so far. We need to increase our orbital lift capacity by 1,000 times. It can be tough to find time to read hundreds of pages with so many distractions around us, which is why we're excited to partner with Blinkist today. Blinkist has the perfect content to help you be a better, smarter, and more knowledgeable you in 2022, and is the only app that condenses nonfiction books to give you the key insights so you can apply those lessons right away. Blinkist has over 5,000 titles in 27 different categories to choose from, which are under 15 minutes. In An Astronaut's Guide to Life on Earth by Chris Hadfield, you learn that on a space mission, preparation is everything, no matter how intelligent or experienced the astronaut. Most astronauts spend most of their days studying and simulating experiences they may never actually go through. This training pushes astronauts to develop a new set of instincts. We might not be going to space, but we want to be prepared for life as much as possible, and Blinkist allows you to digest useful information to better prepare yourself for the unknown. You can learn a lot in a short amount of time with Blinkist. It's one of my favorite apps and provides exceptional value. I would highly recommend trying it out. And right now, Blinkist has a special offer just for our audience. Click the link in my description to start your free 7-day trial with Blinkist and get 25% off of premium membership. And now let's get back to the video. Okay, so all of that to say, if we're going to get humanity rolling as a multiplanetary species, it's going to take a spectacular effort. But what if our boy Elon pulls through and we actually make this Mars colony happen? Let's say we get the Martian city bumping and life is good on the red planet. That's gotta be the limit, right? If just hopping one planet over is so preposterously difficult, then there's no way we could manage to go any further. Well, I would say exactly the opposite. I would even go far as to wager that Mars itself is the great filter for humankind. It's the unfathomable obstacle that we must cross to become interstellar. And once we do that, then we're out there, free to roam the galaxy. The amazing thing about Mars is that it cuts down the difficulty level of getting large amounts of mass into orbit by several orders of magnitude. We're going from expert mode on a video game down to easy. We can see that directly reflected in Elon Musk's plan for the Starship. So, in order to get the ship off the Earth, because our planet is too thick, Starship needs the Super Heavy booster, which is 33 Raptor engines stuffed into the bottom of a stainless steel tube. The thrust from each Raptor version 2 engine is about 245 tons, according to Elon on October 24th, 2021. So about 8,000 tons of thrust in total. That's what it's going to take to get a fully loaded Starship off the Earth and into space and eventually to the surface of Mars. But how does it get back? The cool thing is that the Starship alone can launch itself from the surface of Mars into space, come back to Earth, no Super Heavy booster required. and the Starship only has 3 of the high-pressure sea-level Raptor engines from the booster. That's the difference between launching from Earth and launching from Mars. A 70-meter-tall rocket booster with 33 high-powered rocket motors. The reason for this is pretty simple. Mars is smaller and less dense than the Earth, and therefore has a lower force of gravity, only about 35% as strong as what we know on Earth as 1G. So whatever a spaceship weighs on Earth, it will only be about 1/3 that weight on Mars, while the effective force of thrust from the engines will be the same no matter the location. So if we only take the force of gravity into account by moving your rocket from Earth to Mars, you've effectively tripled the power. That's a pretty good start. Now we can also look at atmospheric pressure, or the density of the planet's atmosphere. On Earth, we have a lot of density in our atmosphere. Anything moving quickly will encounter resistance from the air. We call it thin air, but in reality it's pretty thick. Just by swinging your hand back and forth quickly, you can feel the resistance. In the case of a rocket, that resistance builds up pretty fast, especially a big rocket like a Starship. The more surface area, the more pressure will accumulate on the ship as it goes up. The atmospheric pressure on Earth is about 15 pounds per square inch at sea level, while the ground level pressure on Mars is just 0.09 psi. Not 0.9, 0.09. So basically non-existent. It's more difficult to calculate how exactly that would factor into a rocket launch, like how many multiples this would increase the effective power of a rocket on Mars versus the Earth, but it's going to be a lot. This is the same reason that the Apollo astronauts were able to launch from the surface of the moon using nothing but a rickety old lander in the 1970s. It doesn't take very much force at all to launch from the moon into space. Mars is going to be somewhere in between the moon and Earth in that regard. So our first practical test of what happens when you launch a rocket from the surface of Mars is probably going to happen with the NASA Curiosity rover mission. This is the car-sized rover that is on Mars right now and has been sending back all of these crazy high-res photos of the landscape. One of the ideas for this mission is that Curiosity will collect samples from the Martian surface that will eventually be returned to Earth. Basically, the plan is to send another rover out to meet Curiosity. Right now, NASA are calling this a fetch rover. That second rover would take the handoff of the samples from Curiosity and then load the samples into something called the Mars Ascent Vehicle, which would also come along with the fetch rover. Then the Mars Ascent Vehicle would blast off from the surface into orbit around the planet, and finally, that would meet up with a third vehicle called the Earth Return Orbiter, which would snag the payload and bring it back to Earth. Unless SpaceX really makes some unprecedented progress with the Starship, then this will most likely be the first ever rocket launch from the surface of an extraterrestrial planet. And we will likely learn a lot about the physics of launching from Mars once this attempt goes through, whether it works or not. I imagine it's possible, even likely, that SpaceX might land a Starship on Mars before the NASA sample return mission, but that ship will not be able to take off and return once it gets there. Just the fact that a Starship might be able to reach Mars with enough fuel still remaining to conduct a landing burn is insane. It could not possibly have enough to launch again without refueling on Mars. So, that's why SpaceX has to build a Martian starbase. So, this brings us back to the idea of using Mars as a launching point for our future fleet of rockets. A spaceport on Mars is not only cool as hell, it's also going to be a necessity for two-way travel between Earth and Mars. If we don't at the very least establish a refueling station on Mars, then no one who goes there will be coming back. Some people might be chill with that in the short term, like either die on Earth or die on Mars, pick one, but that's not exactly sustainable. And Elon wants to go even further than just a Martian gas station. He's talking about recreating the ground-based infrastructure for Starship orbital launches on Mars. So the giant robot Mechazilla tower that will eventually be catching rockets for landing on Earth would be doing the same job on Mars. This alone would make the process of landing and relaunching from Mars incredibly efficient. But when you start to imagine a total recreation of the Boca Chica starbase on Mars, Now you have the full capability to build starships and super heavy boosters in this Martian environment, where the capability for these rockets is increased by orders of magnitude. If a Starship Super Heavy can lift 100 tons from the surface of Earth, then it can maybe lift 1,000 tons from the surface of Mars, maybe more. And that's just with the technology that we have now. Who even knows what SpaceX will invent in the next decade that allows us to push the ship even further than what we know to be possible today? And where do we get the resources to build this Martian generation of boosters and ships? Not from the Earth, not even from Mars. We mine asteroids for unlimited resources. This is all about location. Mars is significantly closer to the asteroid belt than the Earth, and launching ships from Mars is significantly more easy than launching ships from the Earth. And even beyond that, landing ships on Mars is easier than landing them on Earth, and by extension, landing giant chunks of asteroid on the surface of Mars is going to be one hell of a lot less complicated than trying to get them down to Earth. No offense to Mars, but we could just crash small asteroids into it all day long, and nobody would really care. So if building and launching a fleet of reusable, heavy-lift spaceships on Earth is, as Elon Musk says, preposterously difficult, then all signs point to that same job being significantly less so from Mars. Obviously, that doesn't happen overnight, but at least it could happen on Mars. As optimistic as we can be, the idea that we could ever build and launch a truly interstellar ship from Earth is just too much. There are too many obstacles to success. Like, if you've seen the end of the movie Don't Look Up, when that gigantic colony ship is flying away from the destroyed Earth, that's a good way to end a movie, but it's entirely detached from reality. Nothing that big could ever launch from the surface of Earth unless it has a rocket booster the size of Manhattan pushing it up. But we could do that from Mars, build and launch some kind of a generational spaceship that goes outward on a multi-century journey into the unknown, literally extending the light of human consciousness to the stars, just like Elon Musk is promising that we will. And that's why Elon is so obsessed with Mars. He knows that planet is the key to everything. Or maybe he just really likes the color red. I'm not entirely sure. That's enough from me for one day, though. Let us know your ideas about a Martian spaceport in the comments section below. And what do you think that looks like 20 years from now or 40 years from now? Are we flying from Mars to Titan? Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.